So let me share my screen real quick. Say yes if you can see the screen. Say no if you cannot. Today we will be going over systems of equations. Okay, yes, very good. So today we will be going over some warm-up problems, just going over every unit, all 4 units from last semester, since we took a week off, which is technically kind of like a spring break or something in between. So hopefully you will be able to finish this entire course before, most of summer break. Then we'll be introducing to systems of equations, which basically is solving, multiple equations with multiple variables. So we've seen this before, but we did not know how to solve it. So today we'll be finally introducing that type of concept. We'll be going over some practice problems. So now let's go to our warm-up problems, which are basically a review of everything. Okay, so they should be pretty fast. If you paid attention last semester, I'll give you just 1 minute to do this. Okay, so let's go over this one. All right, so we should have some answers here. Let me see. What you say? Braden says 2. Yuchen says 2.625. So let's just check real quick. Basically, we have an absolute value, basically like parentheses here. So we're just gonna do whatever is in the absolute value first. That's just going to be 11. So 11 is in the absolute value over 8 plus 15. There's gonna be what? 46 over 23 is just going to be 2. Okay, so make sure you did your calculation correct there. So you have to do the absolute value first, multiplication first, and then you add everything up. So do not add anything before you do the rest of the steps. Now let's move on to this next one. This is basically talking about distributive properties, simplifying expressions. So make sure you know that before we begin our next unit. Okay, so let's check this one. So Ella says 4x minus 3y plus 36, and Yuchen also says the same. So what we need to do here is we need to do the distributive property first. Okay, like so, and then we add the 5 at the end. Clearly, the 5 and 5 cancel out here, so you're just left with 4x plus 40 minus, as you can see, 9 times 1/3 is 3, so we're left with minus 3y plus 9 here. Be careful, these are two negatives that we're multiplying together, so that's going to be a positive. Then we have our plus 5 here. So then what we have here is just going to be 4x minus 3y plus 54. So is that what you guys got? Okay, so Ella got 36, Yu Chen got 26. I don't know. Is something wrong here? Oh, I see the problem. So it's 4/5 times 10. So this is 8, first of all. If it's 8, then that changes things. It's going to be 14 plus 8, which is 22, which still does not match your answers. So does anybody see any problems in my calculations here? I think it should be.
I did when I did -9 times -1, I didn't make it positive or something.
Yeah, I think I'm on my end I made an addition mistake.
Oh, okay. So I think the correct answer should be 22. Okay, let's move on to inequalities. I'm pretty sure we learned inequalities in Unit 3, so not too long ago. You should still remember how to do compound inequalities like this and how to graph them. So I'm going to give you a couple minutes to do these. Okay, let's go and see. So Yuchen says -11 to 7. So x is between -11 and 7. Zemo says x is between -5 and 7. So let's see which one is correct here. And okay, so the first thing you need to do is to get rid of the fraction because nobody likes fractions. So it'll just be easier to work with here. So you have to multiply 2 to both sides. 12 is greater than 3x minus 9 is greater than -24. You want to get x by itself, and you can do it to both sides simultaneously. So you need to add 9 to both sides. You get 21 is greater than 3x is greater than what? This is 15, -15 here. And you should get x is between -5 and 7. Because once you get the 3x here, you just divide all sides by 3 and you get the answer. So once you get this answer with the inequality signs, you can put it into interval notation like this. And you can observe pretty easily that x is going to be an enclosed interval between 2 points. Usually this is what happens with compound inequalities. So you have -5 and 7 here. You're going to have open circles because that represents that is strictly between -5 and 7. It is non-inclusive. So let's go on to the next one. Find the x-intercept and y-intercept of 3y minus 6 is equal to 5/3 times x plus 7. Okay. Let's continue here. So let's see how we can find the x and y intercepts. So the x and y intercepts, 3y minus 6 is equal to 5/3 x plus 7. So clearly we have a line here. It doesn't really matter what we have. To find the x-intercept, we always use the same thing. And also to find the y-intercept, we use the same method every time, which is to set the other variable to 0. To find the x-intercept, y is equal to 0. So you're going to have -6 is equal to 5/3 x plus 7. And then for the y-intercept, x is equal to 0. So 3y minus 6 is equal to 5/3 times 7. So you should be, getting should be solving some equation like this. -6 is equal to 5/3 x plus 35/3. Like that. And then now you can multiply both sides by 3, do whatever. Actually, let's multiply both sides by 3 real quick. It could be easier. So we have what? -18 on this side is equal to 5x plus 35. And then we're going to have -53, I think. X equal to -53/5. That's one of them. And we have the other one, 3y minus 6 is equal to 35/3. We can again multiply both sides by 3. Okay, so 9y minus 18 is equal to 35. And 9y is equal to 53. So y is equal to 53/9. So tell me if you find any calculation errors, because there could be a lot here. But that's basically the concept of what you need to do. So here we set the other variable x is equal to 0. And then we solve for y. That's how you find the y-intercept. So in school, usually the problems, they are a bit nicer, and then you get better numbers. Okay, and finally we need to graph this. Graph the slope-intercept. Graph a line using slope-intercept. So let me see, do I have any volunteers that are willing to graph this or help me through to graph this? If not, I will call on somebody. So Ella, can you graph this? Ella, are you there?
Yeah, is it the question that we just did? Or
This one. 1/4 of x minus 3. Just tell me what to do. I have the coordinate plane here. So how should I graph this?
so 0, -3 for 1 point, and then
The y-intercept, right?
yeah.
The slope is 1/4. So what should we do now?
And then it's at 1, x is 1, y is -3 and 1/4.
Okay, whoa. Let's back up for a second. What is the slope again? Slope
1/4.
is change in y over change in x, right? So you don't need to do all that. If the slope is 1/4, the top one is 1, which is y. The bottom one is 4, which is x. Okay, so what do you need to do first? Do the y first. Move up by 1.
1.
Okay, so we move up by 1 here, and then you go to the right by 4. 1, 2, 3, 4, somewhere around here. This will be your next point. Okay, so this is the fastest way. Or what is 1/4 is also equal to -1/-4. So you can do it other way. You can go down by 1. Okay, so here, go 1, 2, 3, 4. It's here. And it should be on the line. Okay, so using the y-intercept and the slope, we can find another point. And all we need is 2 points to make a line. Okay, so that is all for the warm-up questions. We'll now be going on to systems of equations. Okay, so now here it is, the definition of a system equation: set of simultaneous equations with common solutions that fulfill all equations. So that is what a system of equations is. I'll give you an example real quick of what might happen in a system. So we might have a systems where, x and y are variables. Let's say a, b, c, d are constants, numbers. So this is what might happen in a system. You're given 2 equations with 2 variables, x and y. Actual example, let's say 3x plus 5y equals to 6. 4x minus y is equal to 7. Something like this. And obviously, you cannot solve this first equation by itself and find out which variables are which, right? You have this one variable, okay? You have, no, not one variable. You have these 2 variables, okay? And you only have one equation. You can't solve like that. That's why you need a systems of equations, 2 equations, in order to solve this. And later on, we'll be doing word problems, and you can see how useful the systems of equations are when you apply to real scenarios. So a lot of times you don't just have one equation, you have multiple equations. So here's some methods on how to how to solve a system. Okay, so we're going to be learning about 3 main methods in Algebra 1, or whatever this is called, basic algebra. Okay, so we're going to be learning about graphing, substitution, and elimination. So there's other methods to solve system of equations. You can search it up if you are interested, but it is too advanced for us to cover right now. They're called matrices. You can solve the system of equations, matrices, Kramer's rule, that kind of stuff. But that is part of linear algebra, which is a college level course, which we are not going to be discussing in this course. So we're going to stick with the 3 elementary methods, actually 2 elementary methods, because this one nobody really does. So the first method is just simply graphing our equations. Let's say we have an equation: x plus 2y is equal to 6, and x is equal to y. If you graph these lines, okay, as you can see, you graph the lines, and you want to find a common solution for both of them, right? So then you can find where they intersect, and where they intersect is the solution to the system. And that's very simple until you get any problem that doesn't make a clean graph. Then it's very problematic for you. You don't want to do this. Nobody really graphs it. It's really not worth your time to try and graph all of these and try to find the intersection. It's much better to do it arithmetically or algebraically. But learning how to graph a system and find the intersections is important because you can comprehend what a system is. It's not just 2 equations thrown together. You can visualize them as lines put on the coordinate plane, and the intersection as a solution makes sense because it is the common point of both lines. All right, so hopefully you can understand that. Now let's go on to an actual example. Okay, an actual example where we'll solve it arithmetically with algebra. So by the way, this first graph, the answer would be just the coordinates of this point, 2, 2 here. This would be x is equal to 2, y is equal to 2. Okay. And we usually denote the answers to systems in this notation, 2, 2 coordinate notation for our systems. And if, let's say we have 3, solutions, then it would be x, y, z. So far, before I go on to the substitution method, are there any questions? If there are no questions with this, then I will continue onto the substitution method. So if you know what substitution means, I mean, we've done it before with other things. You substitute in numbers for variables, you substitute in, you substitute in numbers for variables. For example, 3x plus 4, we want to find the value of this. We know x is equal to 2. What do we sub in? We sub in 2 for x. We can say 3 times 2 plus 4 is equal to 10. Okay, but we're not doing that. We're doing that something very similar to that. Instead of subbing in a number for a variable, instead we're subbing in variables for variables. So how do we do this? Let's take the exact same example from last time. X plus 2y is equal to 6 and y is equal to x. You can choose which one you want to sub in for. You see in x here, all we have to do is to make an equation with one variable, because we know how to solve equations with one variables. So let's just do that. Let's take y is equal to x here, and let's put in x as y. Instead of y, we have x here, and that's equal to 6. And then it's very easy now, because we know how to solve these. 3x plus, 3x plus nothing. 3x is equal to 6, and x is equal to 2. Now that you've done that, you can sub in one more time. X is equal to 2. So we just sub in what 2 is into this equation. Y is going to be equal to 2 directly. That's how quick we get it, okay, with the substitution. But of course, you're never going to have such an easy question. Obviously, nobody's going to give you, x is equal to y straight up. So we're going to take a look at another example here and how you can manipulate certain equations to isolate one variable to, substitute. Okay, so let me see how many we have. So you have a good amount of practice problems here. I'm going to use the first one as an example. So we're not clearly given, for example, x is equal to y here. You're usually not going to be given that because it's too easy, right? You're going to be given something like this. So how do we solve something like this? Okay. There's nothing to substitute, nothing equal to. So here's when you want to isolate a single variable. Let's say that you want to sub in y, something in terms of y for x, right? So I see x as a single thing right here, which is great already. So we can take this equation and we can manipulate it in such a way that it's like x isolated. So clearly this is going to be 26 minus 8y, right? X is equal to 26 minus 8y. And now that we've isolated the x, we can substitute this whole thing in for x in the first equation. Let's go back to the first equation and let's see what we get. 5 times 26 minus 8y plus 2y is equal to 16. So after we substituted that whole thing in, we can solve it now. So we get 130 minus 40y plus 2y is equal to 16. Negative 38y is equal to what? Negative 114. And that is just going to be 3. Y is equal to 3. Okay, so now that we have y is equal to 3, we can substitute in y one more time to the first equation. Let's just go up here for a second. 5x plus 2 times 3 is equal to 16, we know that the answer is x is equal to 2. Okay. And now that we found that, you can put your answer in coordinate notation. So 2, 3, like this. Are there any questions on this? Any questions? Okay, if there are no questions, then I will continue on to the next practice problem. So this time you'll be doing exactly what I did, finding one variable, isolating it, and then substituting in whatever you get for that one thing. Okay, so here's what you need to do. 8p plus 7q is equal to 43, and 2p minus 7 is equal to negative q. So please do this one. Okay, let's see what we got here. We have a couple of answers. So Yuchen says 1, 5, x is equal to 1, and y is equal to 5. Okay, Ella says p is equal to 5, q is equal to negative 3. Okay, and then I think Annie got the same answer as Yuchen. So let's see what we have here. So 8p plus 7q is equal to 43. We can't really use that one, so I'm not going to use that one. Instead, I see an isolated q here, which is negative. So we might as well make it positive by multiplying negative 1 to both sides. Q is just going to be equal to 7 minus 2p. Okay, so now that we got that sorted out, we can substitute this in for q. In the first equation here, 8p plus 7 times 7 minus 2p, okay, is going to be equal to 43. And now we need to see what we do with this. It's just one equation, one variable equation. So a p plus 47 minus 14p is equal to 43. And let's see here. We have what, 22p is equal to -4. I don't think that's correct. Let's see. So did anybody get that right now? Let's see what we did wrong here. So we do have this correct. 7 minus 2p like this. We plug it in. Okay, so 8p plus 7 times 7 minus 2p. We should have this, right? So 8p plus, this is not 47, by the way, it's 49. 49 is -6, but still a little bit not what I'm looking for. -6, so according to this answer is -3 over 11 would be p. It's a bit weird. Did anybody get -3 over 11?
I got a different
No.
answer as an ordered pair because I used the graphing method instead.
I used the graphing method.
Yeah.
Okay, let me graph these real quick and let's see what we get here.
I
I
got
don't know.
q equals to -2p plus 7.
Okay, let's see what's wrong here. Give me a second. Okay, so our answer should have been 1, 5. So how did I not get 1, 5 here? Huh. Because they do, when you graph them, they do intersect at 1, 5. But our substitution thing is not working for some reason. Oh. Okay, let's see, troubleshoot what happens here. So, let's see. 8p plus 7q. Everything should be correct, right? It should be correct. But we're not getting the same answer, which is very strange. Okay, so does anybody see any problem with these calculations?
When you multiply like 2p minus 7 equals to negative q, like by -1, I got q equals to -2p plus 7.
Huh? What did you say?
When you multiply 2p minus 7 equals to negative q by -1, I got q equals to -2p plus 7.
This is the same thing. It's just flipped.
Oh, okay.
Okay, give me a second to try to work this out. Something's very weird here. I did not know what is happening. equal to 43. 2x minus 7 is equal to negative y. The answer is that. No idea why it's happening. Huh.
Isn't
What?
8p minus 14p negative 6p?
That's a great question. Oh, I've been doing the wrong thing this whole time because I added them. Huh. The 6p. Okay, nothing is wrong. Wow. That was kind of sad. Anyways, p is equal to what? Yeah. I did not look at that subtraction sign. Okay, somebody should have told earlier. Anyways, now that p is equal to 1. Sorry for the misunderstanding. Everybody who got p is equal to 1 is correct. Now that we got p is equal to 1, we can do the q quite easily here. And that's just equal to 5 because it's 7 minus 2 times 1. That was very sad. Okay. Q is equal to 5. So we should have gone 1, 5. So Yuchen, you did get it correct by graphing. Huh. Okay. Now on to the next one. All right, so let's check the answers for this one. Okay, so let's see. Negative 5a plus b is equal to 8. So immediately you can know that b is equal to 8 plus 5a. And we can use that to substitute in for b in the next equation. 7a is plus 9 times 8 plus 5a is equal to negative 32. We have 7a plus 72 plus 45a is equal to negative 32. And then we have 52a is equal to negative 104. So we have a is equal to negative 2. So whoever got a is equal to negative 2, you're correct. Now on to B, we need to substitute A is equal to -2 in, so -5 times -2 plus B is equal to 8. B is also going to be equal to -2. Okay. Are there any questions? On this one? So Yuchen, you got it correct. So very good job. Let's go to the next one. And this one you might need to do some more work when you're substituting in things. Okay, let's check the answer for this one. So this one, you need to, I'm gonna say, probably have isolate M. So we can isolate M here. 2M is equal to -5 minus 6n. Okay. So then you have to divide this by 2, -5 minus 6n over 2. That's fine. And now we chose M because when we multiply this whole piece of junk here, the 4 and the 2 simplify. Okay. So this 0 here. And we have 2 times -5 minus 6n plus 5n minus 18 is equal to 0. We have -10 minus 12n plus 5n minus 18 is equal to 0. And let's see, we have negative 7n is equal to 28. Therefore, n is equal to negative 4. Okay? So now we need to go n is equal to negative 4 here. We sub that in. Negative 5 is equal to plus negative 24. Okay? So then we have what? We have m is equal to 19. Okay, we have m is equal to 19 over 2, apparently. So let me just check that real quick. 19. Yeah, that should be correct. That should be correct. So 38 minus 20. Yeah, okay, so that is correct. So weird number, but it is correct. So let's say m is equal to x. So 19 over 2 over negative 4. Okay. Now on to the last one. So this one is very easy because we're already given the substitution thing that we put in here. 9u is plus 2 times 2 minus 6u is equal to 3. That's all we need to do. 9u plus 4 minus 12u is equal to 3 here. And then we have negative 3u is equal to negative 1. U is equal to 1/3. Okay. And then we get v is going to be equal to 0. V is equal to 2 minus 2, so it's just equal to 0 here. So are there any questions on, this kind of systems of equations thing? We will be learning learning a new method on how to solve these that can be much faster next class. Okay. So are there any questions?
So just a comment. There are three ways to solve a system of linear equations, but some are faster than others.
Yes, that's true. Realistically, I think substitution would be best when you're straight up given this, right? For example, something like this, where you're not necessarily given an isolated variable, you gotta go and solve for your own. Probably not the best to use substitution. I mean, just waste a bit of time. If you're given exactly this, okay, maybe it's a bit better. Other times you can use something called elimination, which is the method that we'll learn next class. And when you grow older and into higher level math, then they'll teach you about matrices, which can also be pretty fast. And yeah. So there's many methods to use to solve systems, and it really depends on the question. Okay, so you need to be able to recognize which method is the fastest and which one you need to use. Okay, that's all for today, and I'll see you guys next week. Okay.
All
Next
right
week.
then. Thanks.
Thank
Bye.
Yeah, thank you.
Thank you.
See you next week.